Hello everyone, myself Nishant from Sri Venkateswara College of Engineering. Today I am discussing about supervised learning algorithm. First we will see the introduction to supervised learning. Supervised learning is a type of machine learning where the model is trained on labeled data. The goal is to learn mapping from inputs to outputs based on provided example. This approach is widely used in various applications such as classification and regression tasks. Next, we will discuss about key concepts about supervised learning. Labeled data consists of input-output pairs that helps the model learn patterns. Next, it trains and tests the data sets are crucial for evaluating the model performance. Next, it's overfitting and underfittings are common challenges that needs to be addressed during the training. Next, now we'll see the types of supervised learning. There are two main types of supervised learning. One is classification and another one is regression. First, we'll see about classification. What is classification? It is a classification deals with predicting descriptive labels or categories from input data. It will be categorized from the input data. Regression. Next, we'll see the regression. Regression involves predicting continuous value based on the input feature. It will be based on the input features. Next, we will discuss we'll see popular classification algorithm. Mainly three algorithms. One is logistical regression, decision trees, and support vector machines like SVM. You can see the logistical regression example you can see in this diagram. Uh, Logistical regression is a simple yet effective algorithm for a binary classification problem. Next, we'll see the decision tree. Decision trees are in a model that splits the database on values for classification. Support vector machines finds the optimal hyperplans to separate different classes. It used to separate the different classes. Next, we'll see about popular regression algorithm. It's a linear regression model, the relationship between the input features and continuous output. Polynomial regression. In polynomial regression extends linear regression to capture nonlinear relationships. Random forest regression used for enable to decision trees to improve predictive accuracy. Next, we'll see evaluation matrix for classification. Accessoring measure the proportional of current predictive prediction made by the model. Precisions are and recalls provide insights into the model performance on imbalanced datasets. The F1 score combines precisions and recall into a single metric, metric for a better evaluation. Next, we'll see about evaluation matrix for regression. There is a evaluation matrix regression formula. You can see in this is equal to 1 by n summation n 1 to n yi mod of yi minus yj. We can see absolute error. We can see in this mean absolute error, mean squared error, and R squared. Mean absolute error calculates the average absolute difference between predicted and actual value. Next, mean square error. It's enhancing the large error by squaring the difference. Next, R squared includes the proportion of variance in difference between explained by the mode. Next, we'll see about training strategies. In training strategies, cross-validation helps assess model performance by splitting the data into multiple training or testing sets. In this hyperparameter turning optimized model performance by adjusting parameters like learning rates. Next, regulations techniques prevents overfitting by additional penalties for complex model. Next, we'll see about challenges in supervised learning. Mainly, what are the challenges we face in the supervised learning? You can see in this diagram. First, label data and labels are sent to model training and it will be predicted and it will be machine will be categorized accordingly. In this, acquiring a label data can be time consuming and expensive for many applications. Class imbalance in the dataset may lead to base model performance and inaccurate predictions. The choice of algorithm and parameters can be significantly impact the model efficiency. Next, we'll see the features of supervised learning. What are the features we have? Advanced in deep learning and expanding the capability of supervised learning algorithm. Next, it transfers the learning, allows models to leverage knowledge from one domain to enhance the performance in another. Continuous research is focused on making supervised learning more effective and accessible. Thank you for watching.